I hope recording is on, right, Suraksha? Okay. So yeah, so expected value and mean. So in this context of statistical probability, so probability and statistics which are related to ML, expected value and mean are kind of similar things. And variance and covariance are similar things, but they have a subtle difference. Variance here will, like we'll go through each and every topic and we'll understand geometrically how it is actually. So in graph wise, we'll understand how it is. And एक चीज को हम find out करने का मतलब क्या होता है and how it is related to machine learning. So all this stuff we will understand. So expected value and mean, variance and covariance, empirical estimates. Empirical means we do it, with discrete values. We just solve them. So we try to do certain operations to get the, overall, uh, overall, mean and shape of the data. So data when we represent in data points. So if we have, two, 1 second. Mm, So yeah, our motto is to understand this specific part. 1 second. So the tablet is creating certain disturbance. Can you guys help me with 2 seconds? Like I need to restart my PC so that this pen works perfectly. Really sorry. Please stay on this call. I'll join again. Yeah, I'm sorry for the disturbance. So yeah, am I audible, right? I think I'm audible. So in machine learning, like we have data in tables, right? We store data in tables, digital data. So let's say age and income and let's say civil. So these are certain values. Okay. So it can be 22, 23, 22, 25. Income can be in 30K, 40K, 100K, 90K. Civil can be somewhere around 7, 8, 7.7, 9. So here it is a small table, right? So in real world, we'll be having tables which are, thousands and lakhs of rows. So these specific things called features, and these are entries, rows. So these are features, which is x1, x2, x3. These are entries. Like एक एक feature का क्या क्या value होगा. So here each feature is a direction in हमारा ML space जो भी है data. Each thing is a direction. So age यहाँ पे and income and civil. So here in this sample thing we have only three features, but in real life it can be also in hundreds, thousands of things. So the dimensions will be like n dimensional. So then we represent it as r n, or sometimes we represent as d. इसका मतलब है it's a vector space. R is a vector space of d dimensional. So d number of features has it. So this is how we say. Now let's say this specific thing. So let's call this as a certain entry, right? So let's call it as x1 1 x2 1 x2 3. So these are for capital X1. So this is capital X2. This is capital X3. So like these are vectors, and these vectors will be present in this vector space. So because it has d equals to 3 dimensions, so it will be in three-dimensional vector space. So and this will be that how much distance traveled in this direction, and this will be how much distance traveled in this direction. In the same way, you will get the overall vector to be the, these are the components. D components will be there, and overall, resultant vector will be pointing out in certain direction. So this is how you store data in vector space, right? So Abhi, what we are trying to understand, we are understanding the main statistics of these features. So we need to find mean, mode, median of these things, and what is max, what is minimum. All these parts we'll study one by one. So what is statistics? Summary of statistics. The distribution can be infinite complex, as I already told you. How do we summarize it with a handful of numbers? And what does those numbers mean geometrically? So to analyze all those d-dimensional data, it is very difficult. So if we represent them like it is three-dimensional space, and it's already complicated for us to imagine how data moves and how the vectors are aligned with each other. So we need to understand like ये वाला जो entry है, how it is aligned with this वाला entry. So it is very difficult to understand the angles between them and everything. So we need to find certain numbers, certain constraints from the data, so that we are we will be understanding the overall, you know uh, characteristics of the data. So we are choosing certain parameters, certain characteristics, certain constraints that will explain the data of any big dimensions. So we want to generalize this understanding of data, no matter if it is two-dimensional, one-dimensional, or n-dimensional. So what we'll cover today is about covariance, mean covariance, estimates of data, empirical estimates, and what are the three kinds of variance we have, and what is statistical independence between two features, and what happens when we think random variables as vectors. Okay, so first one, for continuous random variables. So I hope everyone knows by now what is random variable is, right? It is a function. So the expectation ex is the expectation of that specific function. So we already told you it will be the a summation of all those products. That will be the expectation or probability, whatever it is. For discrete, we do sigma, and for continuous, we'll do the integral. So E is a linear operator. So here E is like the linear operator. It is of 1 degree, of no matter if it is F or G, right? So the coefficients will be A and B for that. The expected value is the center of mass of the distribution, the balance point, if you place mass P of X at each location. So graphically, if you have a data like this, so you are pointing all data points in two-dimensional space, x1 and x2. So we have two features here, and we are pointing all the data points in two-dimensional space in a plane. So it is the center of mass of that specific data. So it will be in the center, and it will represent as the core thing, that is mean. So what do you mean by mean? It is the average of all other observations, right? So this mean is the center of mass. Like if you think, if these points are cloud, then you will say that this is the center, and here the whole data whole mass lies. So if it is a mass, this is the center of mass, and that is represented by this is mean. Okay, so that is what it is saying about. So three averages in 1D: mean, center of mass, median, 50% split point. So at the point where you can split it in two parts, and mode, it is the peak of px. So px का जो peak है, that is mode, and the center of mass is mean, and the point at which you can split it into two parts, it's median. For skewed and heavily tailed distribution, the three differ, and the median is more robust than for the outliers. So for example, if you have certain persons with a height, इनका ऐसे है, so ऐसा है, and you got so these are heights. This is persons, let's say x, x1, x2, x3, discrete. It is not continuous. And यहाँ पे height है h. So you got a mean like this. Okay, यहाँ पे mean है. So what it does is it will add all these things and subtract number of observation, number of existing things. So total number of things and sum of all things. So it will give this specific height line, right? It will say that average person has this much height. So this is person 1, person 2, person 3. This is person n. So this will say the mean, this will be the mean average of that thing. And if you take mode, so number of same height persons, it will say certain thing about the data. And if you take median, so let's say you have median, and you have median ka height, when you keep it in thing, it's like this. So generally what we do is all of those things will be in ascending order, right? Or descending order. We keep them like this. Like this we do it. So ये तो बढ़ता जाएगा. And you will take median, and you will say this is the this will, like, mode, median, and mean. What they do, they represent data, right? So this is median. So outlier, like this is very, very, like there is another observation. This is very much big height, right? If we do average, initially with for this data, average was this. Okay. Because we included this, average increased up to here because summation में value increase होता है. But median for this data will be this. And for this data, it will be this or this. ज़्यादा difference नहीं होगा. If यहाँ पे थोड़ा ही like height ज़्यादा है, but here this is very very big, right? Very very big number. So median जो है, so that is not the best thing which represents outliers. Like पूरा data set को साथ में लेके जाने वाला thing, the constraint is mean, not median. So it is very much robust to outliers. It does not explain it well. So next, yeah, next we're gonna mean, mode, median, bimodal example. So in bimodal distributions, two modes, two peaks, mean sits in the valley. यहाँ पे not a likely. Median tracks human intuitions better. So median जो है, it will this tracks human intuition better. So यहाँ पे what is unimodal and bimodal things, right? Bimodal में we will be speaking about two different things of equation, two different equations which are explaining two different parts of single data. So if a single equation is used to understand the whole data, that is unimodal. If you take linear regression or linear regression represents the data, right, with a single line equation. So that is unimodal. So if you take two different models to understand the data, it is bimodal. So mixture models, GMMs, explicitly model multimodal distributions. The posterior in Bayesian deep learning is often multimodal. Mean alone is misleading. So Bayesian, I think it is unnecessary to speak about this. It will make things complicated. So here what they're saying is multimodal distributions, matlab jahan pe audio, video, and text and another thing is image, right? So these things when are represented in features, so everything will be in features, right, in numbers. So when they represent them in those distributions, the posterior in Bayesian deep learning, posterior is the prediction. We already spoke about it yesterday. Is often multimodal, right? Mean alone cannot mean like पूरा ये जो distribution है, you need to understand the relationship between mean, median and mode. तो तब जाके आपको पता चलेगा कि क्या actual shape of that and how vast the distribution is spread. So to understand those things, you need to understand the relationships also, the correlation of two features, and only mean it is misleading. So what I'm trying to say is, uh, let's say, so there is a circle which is centered at 0, 0, right? So यहाँ पे more mean जो है, it is centered around 0. So mean हो जाएगा 0 because it is centered here, right? I take another data set which is also centered at 0. So what is the difference between this distribution and this distribution? It cannot capture alone mean, because most of the times normal distribution मतलब जिसका mu is 0 and sigma square is 1. Sigma square is square of you know variance. It's variance. So I hope understand like mean क्या होता है, covariance. I will speak about this later because we are not there yet. Next topic is this. So these two parameters will be considered for a data. So एक डेटा सेट ऐसे हो गया जिसका मीन 0 है एंड दूसरा डेटा सेट विद अनदर डिस्ट्रीब्यूशन, इट इज आल्सो centered at 0. सेंटर्ड मतलब मैं ऑलरेडी बोला था, सेंटर ऑफ मास इज मीन एंड इट इज सेंटर्ड एट जीरो, इसका मतलब है मीन इज जीरो. So for both distributions, mean is zero, but we cannot differentiate between two distributions just basis on mean. That's what it is trying to say. Variance spread around mean. तो data जो भी है, data points, how spread they are around mean, so that is variance. So अगर मेरा एक डाटा पॉइंट है 2, 3, राइट, एंड दूसरा डाटा पॉइंट है दिस इज मीन, ओके, दिस इज 3, 3. सो वी वांट टू अंडरस्टैंड कि ये कितना स्प्रेड है, कितना दूर है. So in squared length, this is squared length because we are using square here. And why we are using square, that also is very important. We will understand about it. So let's take this example. So if we join this will be y equals to 3, right? तो इसका डिफरेंस क्या हो गया, -1, 0. दैट इज नेगेटिव डायरेक्शन में 1 unit, and vertically there is no change. So what we are doing is we want to understand the matrix of this thing. So ये आगे जाके आएगा. So for now you just understand कि कितना दूर पे है. So 1 unit दूर पे है, and in which direction, negative direction. So this is this thing spread around the mean, like mean से कितना दूर है. So here this is mean. This is mean and this is another data point. So yeah, standard deviation is you take this. So v is nothing but variance of x. So mean से कितना माइनस करेंगे, डिफरेंस करेंगे, उसका स्क्वायर करेंगे, and that will be square error, right? New will be the mean. So this one we already saw in previous thing. This is how you represent mean, and ये mean को हम माइनस करेंगे, like this minus this, and उसको स्क्वायर करेंगे. So we don't want to subtract the differences again. So differences can be in positive, 0 or negative, right? We want absolute values. So instead of taking mod, why did we take square? तो इसका दो reasons mainly बोला जाता है कि one is, so जब mod लोगे तो 0 के पास वो differentiable नहीं होता है, and to make smooth computation about differentiation and all this stuff, to make it as a curve. So we take degree 2. That's why we square it. So square करने से क्या फायदा, और एक फायदा क्या होगा? So if these are the differences, so छोटा वाला भी थोड़ा बहुत बढ़ेगा, and बड़ा वाला it will be exaggerating it. So इससे you are magnifying the data square करने से, right? And if it is from 0 and 1, अगर x इसके अंदर है तो 1/2 into 1/2 कितना होगा, 1/4 होगा. So it will be minimizing for this thing. So this is how you just compress and elongate the data. Data मतलब उनका differences, so that you will understand the better differences between each, what is the relationship with how spread it is from the mean. So that's the thing. So first thing is about the graph part. I said here it is not differentiable. Differentiable नहीं होगा क्योंकि if it is like this, like ऐसे ऐसे differentiate करके यहाँ पे horizontal हो जाएगा, but यहाँ पे it won't be differentiable. So there is no differentiation here, right? यहाँ पे differentiate नहीं होगा. And second part is to exaggerate, like to make the curve smooth for easy computation. And third is to magnify, and also this specific domain के लिए वो minimize करता है. So yeah, यहाँ पे new, this is the mean, right? This specific part is mean, and this peak is mode, right? So यहाँ पे ये वाला जो curve है describes about v वाला part, variance. So यहाँ पे this is okay, this part is okay, but this पर्टिकुलर पार्ट पे डाटा डिस्ट्रीब्यूशन जो है बहुत ज़्यादा स्प्रेड हुआ है, सो इसलिए एट दिस पर्टिकुलर पार्ट द वेरिएंस इज ज़्यादा. Moment of inertia of probability mass and the mean, right? Random variable with v equals to 0 is deterministic. तो जहाँ पे ये चीज इक्वल्स टू 0 हो जाएगा, इसका मतलब क्या होगा? रैंडम वेरिएबल जिसका वेरिएंस 0 हो, तो उसका मीनिंग क्या है? कैन एनीवन से? चलो आगे जाके आपको समझ में ही आ जाएगा, यू विल गेट आंसर. सो दिस इज v, like the error request to passes through data. So यहाँ पे ये वाला कैलकुलेट करने के लिए you want to know you know uh, the mean होगा तो तभी जाके ये कर सकते हैं. So there will be two passes to solve this. So instead of that, for better computation, what they do is x को स्क्वायर करके इसका probability निकालेंगे, and probability निकालने के बाद एक चीज को पूरा इसको स्क्वायर कर लेते हैं. So this same values will be coming for both of them. So you can try it doing, with a small example, let us say you will get the same thing. So you take 2 comma 4 comma 6. So ये हो गया mean, right? Total 12 by 3, right? So a mean हो गया. You try to solve it in this method, and this method you will get somewhere 2 point something something. Same value आएगा. And pair wise, यहाँ पे पहला जो फॉर्मूला है, it will directly compute, डिफरेंसेस क्या है, लाइक x और x डैश का डिफरेंस क्या है, उसका होल स्क्वायर, ऐसे करके समेशन करता है, राइट. बट सेकंड वाला में क्या करते हैं हम? तो हम यहाँ इसको पहले क्या करते हैं, स्क्वायर करते, स्क्वायर करके इसका जोड़ देते हैं, एंड उसको माइनस करते हैं किससे? या सो ओवरऑल व्हेन यू डू दिस स्टफ, ओवरऑल स्क्वायर. एंड थर्ड वाला इज पेयर वाइज, 1 by n square into sigma I minus z, like consecutive numbers, like 2 loops चलाएंगे यहाँ भी, एंड 2 से मल्टीप्लाई करते हैं. यहाँ पे क्या हो रहा है? we are trying to do the difference between 2 4 6, right? So 2 और 4 का रिलेशन, 2 और 6 का रिलेशन, अगेन 4 से 2 का डायरेक्शन में, एंड 4 से 6 का डायरेक्शन में, एंड 6 से 2 का डायरेक्शन में, एंड 6 का 4 का डायरेक्शन में. So you are doing all possible combinations again here. So this is why this is computationally heavy. So you will subtract all this stuff, and you apply this formula again, so that you will understand in which direction both relatively how they are placed to each other, each data point. So that's what you want to know when you do this pairwise wala analysis. So this is computationally heavy. So mostly people do this stuff because n loops लगेंगे इसमें. So big of n होगा इसका computation, and इसमें ये is not about time complexity. It is about computation power. All three expressions are equivalent. Each expression 3 shows variance average pairwise distance square divided by 2, and linking spread to distance between the point. So spread को हम कैसे, in terms of what we are understanding, like एक data है. So if we have a data, we have certain numbers, and इसका mean जो है वो यहाँ पे, ठीक है. In first case you are saying uh, how far all of them from mean. So ये वाला distance को देख रहे हो. So in each for each data point, we are checking the distance between them. We are taking that. So that is one way, or else you compute the same thing using different second formula, which will take linear time computation. And ये लास्ट वाला क्या बोलेगा? So last वाला में if I talk speak about the same data points, a particular thing it will understand the like this difference between all points. एक point से सबको you want to understand how they are related to each other. So computationally, it is very, very big, right? You can already see. So this point also, it will be connecting to all different points. So for certain algorithms in ML, this computation is very, very big. क्योंकि कुछ हजार होंगे, like in thousands, you will be having data points. The number of data points will be the same as the number of you know rows we have here. So that's how it works. So you need to make it simple and worth using in deployment, right? That's the motto. So covariance. So this is the next specific thing which almost everybody confused. Literally, I have also confused whenever I read it after a long time. So covariance is something which will, it is mainly kind of matrix kind of thing. Okay. यहाँ पे ये क्या करेगा? It will try to understand the shape of data, how it is aligned and how features are aligned with each other. So here I'll give a small example. Same example I'll give here. Okay. Two examples I'll give. It will be better for understanding. So एक हो गया 2, 3. This is a data point and इसका mean जो है that is 3, 3. यहाँ पे -1, 0 का difference है, right? And so ये वाला जो line है that is y equals to 3. If you plot it, right? So we'll put it in 2 cross 2, like we want to get a matrix from it, right? So -1, 0. यहाँ पे -1, 0. So what we did is जो भी यहाँ पे ये आया है उसको सेम ट्रांसपोज के साथ यहाँ पे कर लिया है. They do the same thing here. You will get this matrix. So 1 हो गया, 0 हो गया, 0, 0 आ गया, right? Matrix multiplication. So this is 2, 1 and this is 1 cross 2. So we'll get something 2 cross 2. So this specific part tells something, and these upper boundaries, upper triangle and lower triangle will say something. So these diagonal entries, each variable is an own spread. So ये कितना दूर पे है वो बताएगा, कितना drift हुआ है. So in this is x direction. In x direction, these points are, in this 1 unit का distance पे spread हुआ है. And in y direction, because they are on the same line, y direction में ज़्यादा spread नहीं हुआ है. So 0 spread. And यहाँ पे 0, 0, what it signifies is how pairs co-vary. Like ये वाला pair कैसे vary करता है, क्या relationship में vary करता है. Because this line is y equals to 3, there is no relation between x and y, right? तो यहाँ पे x1 या फिर यहाँ पे x2 बोलते हैं, because two are two features. So here it should not be y, it should be x2, because this is also feature and this is also a feature. So, but to understand, this is nothing but x2 is equals to 0 times x1 plus 3, right? If you substitute 0 here, you will get 3 in this line. So if you substitute any x, you will get 3 as answer. That is nothing but 3 equals to, y equals to 3 wala line. So what it is saying, like, no matter what is the change in x, it is not affecting x2. So that's why this is 0. So in x direction also, if you change something, there is no difference in another thing. And if you change this also, there is no effect on this. So these are linearly independent. So so that's why we'll understand this specific matrix gives information about how 2 points like a point is spread from mean, and a wala part and a wala part, it will say how like like correlation, not correlation. Here we need to use how together they are varying. So co-vary kaise karna hai? This is the word. So how x1, x2 are varying with each other. So that it will say. So if both of these values, if one are one, both are if positive or both are negative, here it is 0, comma 0, right? It is not varying. If it is positive and positive, positive and negative, negative and positive and positive and negative, इस दोनों केस में they are varying together in single direction. Okay, but here they are negatively varying. So that's the thing. So दूसरा example अगर मैं लूँ, तो I'll take something which is यहाँ पे x1 and यहाँ पे x2. Now I'll take another example. Let's say 2, 2 हो गया. Here 2, sorry 3, 3 हो गया. So this is on this line now. Okay, y equals to x. अभी x का quotient जो है that is 1. So इसका difference क्या आएगा? -1 आ जाएगा. So if you want to create that matrix, you will multiply with its transpose. So you will get -1 and -1. Then you will get 1, 1, 1, 1. That is in x direction. It is drifted by 1. In y direction, it is drifted by 1. And for 1 unit, it is also like for if x changes with one value, this is also changing with one value. If y changing in one unit, it's also changing. So both are like 1, 1. ये वाला ये वाला. This is spread. This is already the diagonal part. Speaking about this, यहाँ पे 1, 1 आया. जब 1, 1 आया, इसका मतलब है they are moving in similar direction, same direction. Okay, that's the point. If I take another example where यहाँ पे, let's say I have like this in this direction, we will get the same thing, but in the same way, right? But if you take an example where you in the matrix you get this negative and this positive, or this positive or this one negative, इसका मतलब है दो points दो अलग-अलग points से जा रहा है. So if you take a median 3, 3 and you take different points, यहाँ पे एक point लगाओ which is -1, -1, let's say, and यहाँ पे एक और एक point लेना which is 5, 5. Okay, so at this particular point, if you do things, this is going in this direction, this point, and this point is going in this direction, so it will be different. So if I take data distribution which is circular, so it is not moving in any specific direction. So what you say is the variance is 0, and it is not spreading in any direction meaningfully. Or if you have a data, so which is like this, इसका मतलब है it is moving in certain direction, right? Then you can say with x it is also increasing. So you can say the covariance of x1 and यहाँ पे x2 is in similar direction. So you will say positively co-varying. Or if it is like this, negative direction, what do you do with x? This is decreasing, so this is negatively co-varying. So this is how you need to understand covariance. You do the same thing, and at last you will divide it by number of things. You will get an overall understanding. right? You'll sum all of these things. So for each row, you will do this stuff. You will add all of them. You divide by number of rows, and this will give you the this stuff. So this is mean. This part is covariance. Here you just sum all these things, and यहाँ पे you sum all this stuff. Get covariance. See here. The shape is like this. So ऐसे shape आ रहा है. It's what is. So red dot is the mean. Dashed lines is the deviation used, and the ellipse is the shape encoded by this part. So this specific thing, because we are studying the relation between two different features, we'll understand the same. The unbiased estimate use this specific thing. So this I need to study again. I was stuck about this specific part, like biased versus unbiased estimations kya hota hai. I will get how it works. Next, sum and affine transformations of random variable. So you have two random variables. We already yesterday we solved this. Like probability of two different things, if they are disjoint, linearly independent, then you can say P of X plus P of Y, right? Right. The same thing here. So variance को भी same चीज होगा. But variance में क्या है? You will get the this part, right? Covariance also you will get. So matrix के अंदर covariance आएगा. You need to take the covariance like to अगर so it need not to be 90 degrees every time. This is x1 or this is x2 and x1. It can be like this or something at certain angle. This is certain angle, right? So यहाँ पे chances the covariance of this specific part and this specific part, and overall this combination will give you like P of X plus P of Y plus P of X given Y and P of Y given X. So here, because they are disjoint, both are same. That's why you will get P of X plus P of Y plus 2 times of any of these. So that is what here we are saying. That's how we get it. If both are independent. So अगर पूरा दोनों independent है, then there is no such thing called the zero. We already saw it became zero here in this example. So you just replace these values by zero. So you'll get this part. And यहाँ पे you see this. पहले ऐसा था distribution and new ऐसा था, and when you transformed it like this in a linear form, what you did, इसका जो x में चेंज किया है y में भी चेंज किया है. इसका मतलब ये है कि you changed in m, that is slope, right? Let's say there is an example of line. So y equals to ax plus by plus c. Another way of representing it is y equals to यहाँ पे 0. ए और बी के अंदर चेंज करेंगे तो m चेंज होगा. c को चेंज करेंगे तो m को चेंज करने से ऐसे एक लाइन है तो ऐसा भी हो सकता है, ऐसा भी हो सकता है, राइट? बिकॉज ऑफ m. c की वजह से अगर लाइन ऐसा है तो इट विल गो अप और डाउन, राइट? और इट विल गो दिस साइड और इट विल गो दिस साइड. 4 डायरेक्शंस. 4 डायरेक्शंस कब? जब हम x में चेंज करेंगे. सो आई शुड नॉट टेक दिस टू लाइन. ओनली y डायरेक्शन में चेंज होगा क्योंकि वी आर एडिंग कांस्टेंट इन y डायरेक्शन. So for a line like this, it will go up or down. So if you add an x, it will go this side or this side, like that. So यहाँ पे भी हम distribution को पूरा distribution को ऐसे हम transform कर रहे हैं. So पहले circular था and you have a new here, and we changed it to like this, नया वाला, and we did this specific operation. Right, ये वाला part क्या था? We already studied ऊपर. So X and Y, matlab, what is the covariance between this specific part and this specific part. So the A rotates and scales up in a covariance eclipse. So यहाँ पे वो rotation भी होता है and it will bend like ऐसे ऐसे contract भी होता है and this will become like this. That's what they are saying. Though they are trying to squeeze this distribution. And squeeze करने के बाद drift भी किया है, like ऊपर भी चला दिया because of this specific B. And B shifts the mean, no effect on the shape. So B will shift it upwards or downwards. So the shape will be the same. Neural networks layers are repeated affine transforms of the feature distributions. So neural networks, what they do is they put it in a very long, W naught plus W1 X1 plus W2 X2 plus W3 X3. Right. ऐसे तो बहुत लंबा चीज होता है. So इसकी वजह से it will transform the features into a meaningful, instances. Statistical independence. If y random variable and x random variable are statistically independent, I already told you. So, यहाँ पे the joint probability of this specific part and this specific part, I say joint probability. So क्या होगा? Like it will be the product of both, right? Like दोनों अगर independent है purely, then इसका मतलब ये है कि अगर ये वाला होने का चांसेस इतना है एंड ये वाला होने का चांसेस इतना है, सो ओवरऑल इसको मल्टीप्लाई करेंगे तो ओवरऑल दोनों में कुछ ना कुछ हो ही जाएगा. अगर दोनों भी होना है, लाइक हियर व्हेन यू से इट इज एंड, बट मेरे को अभी जैसे क्या हो रहा है काउंट 10 में खुल रहा है, मेरे को काउंट 3 कर रहा है. और तो यहाँ पे एंड का मतलब ये है कि वी आर सेइंग दिस स्पेसिफिक पार्ट, राइट. बट ये खुद हो जाएगा. This will be happening because these are disjoint now. मतलब ये जो तुमने मैसेज लिख के भेजा है, फिर इतना ही बस चेंज करना है ना, और कुछ नहीं करना है. These are disjoint. So you find out the probability of this thing and this thing, you just multiply. So that's the part. Consequences of independence. So this will become this, as I already told you. There is no condition for this. So there is no relation between this x2 and this x1. Both are different features. So this will be this part. Knowing x tells us nothing about y, right? So x1 पता होने से x2 में हमको ज़्यादा कुछ फर्क नहीं पड़ता है क्योंकि they are not related. And यहाँ पे this is also the same thing. And यहाँ पे जो term था p of something covariance वाला, वो पूरा उड़ गया क्योंकि we have zero. And covariance zero होने का मतलब ये नहीं है कि they are independent. Like linearly we can say that we should understand, like when covariance is zero, they are not independent. They are like covariance only measures the linear independence, right? Because we are taking the distance stuff. So linearly independent हो सकता है, लेकिन इसका मतलब ये नहीं है कि like 2 degrees में वो independent है. So quadratic way में वो dependent हो सकता है. So linearly independence is the conclusion we can draw when covariance is zero, right? So this is the whole thing. So यहाँ पे y equals to x square है and इसका जो mean है covariance है and everything is zero here. इसका मतलब ये नहीं कि this x is not affecting y. So they are bound by certain thing, but not linearly. That's it. Conditional independence. I think it will be kind of difficult for me to make you understand this thing because my intuition for this specific part is not that great. That's why I asked Shubhang Bhaiya to explain this. Is he in the class? Don't think so. Okay, let me try it. So conditional dependence, right? If x is perpendicular, so let me study with you itself. This is x and this is y, and these are perpendicular for a given z. So p of x comma y for a given z is p of this thing and this thing. So so the relation between x and y is indirectly understood by z. So once you get the z, you will try to understand, how they are related. So for example, if I take an example, कि rain होने वाला है, and another event which I can take is, let's say I will use umbrella. So the chances of being rain and the chances of being umbrella, it is only understood by another specific thing कि rain हुआ है कि नहीं, right? So that will be the z. So x will be first event, y will be the second event. I mean random variable, and z will be the last random variable. So I hope you understood. Wait, let me write it here itself. ये बोल रहा हूँ कि x होगा whether rain or no rain. Okay, and ये होगा use umbrella or not use umbrella. So this will be like actually rain हुआ कि नहीं. Okay, so to understand the relation between these two stuff, we need to understand the relation between x and z, and here z and x. So for given z, like already हमको ये वाला पता है. So knowing y adds nothing about z. So ये वाला dependent है इसमें, ये वाला dependent है इसमें. X is not you know perpendicular to y, but x is perpendicular y just because of z. हमको ये z पता है, इसकी वजह से y is perpendicular to x. That's what it is trying to say. And classical example हम ये दे सकते हैं, see, like z is the season, x is the ice cream sales, and y is the drowning rate. Okay, x and y are correlated, but only because of you know x and y are correlated, but only because both depend on z. Z क्या है? Season. Season की वजह से आइसक्रीम बिकते हैं, and season की वजह से drowning rate भी ज्यादा है. Given season they are independent. So ये जानने के बाद y से ये related नहीं होता. जानने से पहले they are related to individually, they are related to y. So this is, I don't think it made any sense for you. Mm, better intuition I need to get. So yeah, let's skip this part. I don't want to waste your time. I will come with a better example. I will discuss it in the group itself. So another thing is, yeah, inner product of a random variable, right? So यहाँ पे inner product we can put it as a triangle, and जब वो covariance 0 हो जाएगा, तो यहाँ पे x हो जाएगा, यहाँ पे y हो जाएगा, यहाँ पे इनका दोनों का होगा, दोनों का एक. प्रोवाइडेड यहाँ e ऑलरेडी स्क्वायर में है, तो it should satisfy it. So covariance of this is this, and this is sigma, and this will be the angle here. Correlation is the cosine angle between two random variables when we treat them as vectors in a function space. Uncorrelated matlab orthogonal. So if they are not correlated, then they are orthogonal. Correlation one हो गया इसका मतलब है they are in parallel. So there is a linear relationship. So parallel का मतलब ये नहीं कि they are not on the same vector space. इसका मतलब ये हो सकता है ऐसे है और they are moving in similar direction or they are एक के ऊपर ही एक है. So this is where you need to understand like एक x जाने like when we see the drift in x1, so x2 भी drift हो रहा है. That specific thing is they are positively correlated and they are linear as well. And if they are orthogonal to each other, इसका मतलब है उनका theta is 90 and cos 90 is 0 and overall जो dependence है वो 0 हो जाएगा. So यहाँ पे cos is equals to 0 when they are orthogonal 90 degrees में हो. That's the point. So here I want to show a better image which is inside this book. So yeah. So because we are here using variance which is already in square, when we take the root of that variance, you will bring back those value to the same scale. So a is another event, like another variable, and this is another variable. And this specific part is the combination of both things. So if you take x plus y, that is nothing but independent because the angle is theta. So these are independent. So you can write directly this. And overall you take square root because inside wala jo bhi hai, that is already, you know, is already in square. So we already squared it while calculating units, right? So हमको ये वाला पता है कि x plus y जो है, that is where of x plus where of y. तो इसको स्क्वायर करेंगे दोनों साइड्स. तो I mean, this specific part itself is in, we squared the length twice. We multiplied it twice, so it is in already square power. So इसका scale जो है वो normal nu से ज़्यादा है. Nu का जो scale है उसको square करेंगे तो ये वाला where का scale आएगा. तो we need to take square root of it, right? That specific thing only they are saying. That's why they are equal. And क्योंकि यहाँ पे दूसरा टर्म भी होता है 2 into where of that specific thing, but ये वाला टर्म भी होता है combination of x and y, but ये वाला 0 है, so directly we are taking this. Why these are 0? Because that diagram, that specific diagram, you can see they are orthogonal actually. So yeah, here you can see the same formula. See here. Yep. So correlation is nothing but the cosine angle between two random variables x1 and x2. अगर उनका हम एंगल निकालेंगे, then we can say कि वो लोग कितना similar है. Direction is nothing but इसका meaning, right? In machine learning. तो ये बताएगा कि ये दो features कितना closely जा रहे हैं. So what is the use of understanding this? So if you have 1,000 features and you have like 200 features in a such a way that they're so close, like so close. हमारा डाटा सेट में इंचेस के अंदर एक कॉलम है एंड सेंटीमीटर्स के अंदर एक कॉलम है. So इनका जो relationship है, it is very close because it's nothing but the same quantity but in different scales, right? What you do is instead of taking two, you take only one because जो भी ये contribute कर रहा है model understanding को, ये भी वही चीज कर रहा है. So instead of making the dimensions very large, very big, you just compress them. So that's the thing which it can do. So वेक्टर मानेंगे रैंडम वेरिएबल को, दिस इज एक्स एंड वाई. लेंथ जो है वो स्टैंडर्ड डिविएशन हो जाएगा. ओके. डॉट प्रोडक्ट जो है वो कोवेरिएंस बताएगा. The angle between them, so this will be a numeric and it will give you a matrix as well, right? ये diagonal में क्या होगा and ये वाला part क्या होगा, we already discussed. And angle जो है, that is the correlation of you know that specific to thing. And orthogonal होगा तो they are uncorrelated. इसका मतलब है पूरा zero हो जाएगा because of theta is small and cos theta is zero. So here it is cosine angle theta. Pythagoras, we already saw the diagram of it. Token embeddings in LLMs are vectors. Dot products are attentions. So vector space में हम जब vectors पास पास होंगे जहाँ theta is very small, इसका मतलब है वो एक स्पेसिफिक डोमेन के अंदर बात कर रहा है. लाइक यहाँ पे डॉक्टर एंड यहाँ पे स्टेथोस्कोप, लाइक द टूल जो भी है स्टेथोस्कोप. एंड यहाँ पे let's say you have some medicines from them. So everything is related to one specific medical domain. So those specific things will be stored close to each other. And for example, if I say I speak about shampoo and speak about gold, so gold will be somewhere here because they are not that much relevant to each other. That's why the distance, the angle between them is very large. और ब्रश ले लेंगे तो ब्रश ये पास में होगा क्योंकि these are related. That's what it is trying to say. Covariance style similarity. The whole transformer is linear algebra on it. So you just deal with this, vectors there. So ये ideas जो है वो कहाँ ML में काम आता है. So PCA is principal component analysis. So we understand what all components, what are features are principal main for the whole model. So if we have certain a data which is widespread. Let's say what you do is you have data something like this. वो components को it is going in this direction, but ये वाला data बहुत सारे features जो है it is misleading. So what it does is it pushes everything like this. यहाँ पे पहले होगा इसका mean, यहाँ पे कहीं it bring backs to zero. So यहाँ पे mean हो जाएगा and it squeezes from, it pushes everything from sides. So it will be centered at zero. Mean will be zero, and it will capture the whole easy shape of the distribution. And ये वाला जो line है, that is the main line of its this line represents the data distribution, so it will align that specific thing on this line. So it is, I'm not going in depth of PCA. So this is actually what it does. Linear regression mein we already know, like we have a line which represents the whole data points. If you have a data point, ऐसे data points है, you take a line which is best representing that specific data set. So यहाँ पे ये जो है ये errors होंगे, and जो line अच्छे से represent करेगा, the best fit line will be having the least error. And these are like, I don't want to explain because this is kind of research oriented stuff, and if I try to explain about this Gaussian noise and everything, it will be difficult for you to understand. Attention तो मैं पहले RLF जब बढ़ाया था, we already spoke about you know we already spoke about attention mechanism and also reasoning mechanism in LLMs. So two types of things will happen in LLMs. So attention will be calculated because of the covariance type. You will understand how similar each word with the next token. So that's how you understand. So that thing will come in LLMs. And neural nets, already I said a big equation we can write like omega naught से omega n तक you will write all specific equations, right? I said. So that transformation is done in neural networks because neural networks कैसे होते हैं? It will be like nodes, each and everything will be connected to each other, right? Will be connecting everything, and each and every line is a linear combination. Each line is a linear combination. Each line मतलब ये वाला part, each node, it will be a function of these things. So here it will be for this specific node 1, 2, 3, 4. So this will be x1 and x2, x3, and x4. You'll write a equation with certain coefficients. So a x1 plus b x2 plus c x3 plus d x4. Right. So this is tweaking, and last you will add a bias that is b. That is what it is saying. So neural networks में ये चीज होता है. Repeated affine transformations. Hmm. Recenter the mean and rescale the variance for the layer. That is batch normalization. And diffusion models में I already spoke about diffusion models. Like agar you take a data set of images. So let's say each image has 2 pixels only. One pixel is in white and another pixel is in Z. I mean black. यहाँ पे white आएगा, यहाँ पे black आएगा, right? And you have a data which represents a points. Each and every point is. I'm taking an example data set like this. Each point here is an image. Okay. Diffusion model में पहले noising करता है. So each data point को you will add certain noise in steps. So what it does is it will take a single point, मतलब सब points को simultaneously करता है. What it does is it will make it move in different direction, random directions. So it will be somewhere like this. So it can be somewhere like this. So this is t equals to 0. This is t equals to 1. This is t equals to 2. And here let's say t equals to 100. So ये पूरा डिस्टर्ब कर लिया है. So क्लियर इमेज को हम पूरा रैंडम नॉइस बना दिया है. नॉइस एंड इट इज क्लियर इमेज. दिस इज क्लियर इमेज. तो पूरा नॉइस बन गया है यहाँ पे. मूव हो. एंड इन नेक्स्ट स्टेप वी ट्रेन न्यूरल नेटवर्क्स टू ब्रिंग फ्रॉम दिस पोजीशन टू दिस पोजीशन अगेन. तब जाके क्या होगा, बेस्ड ऑन all specific images like this, it will turn everything into Gaussian noise because it understands how to denoise, how to bring back the same photo to the same distribution. It will create the new realistic images. So if you train a model with a lot of cat images, it will go and make it pure noise, and when it will train a neural network to denoise the image, and it will come to certain specific part of this part. So ये वाला जो distribution है, डिस्ट्रीब्यूशन के अंदर दूसरा एनी न्यू पॉइंट वो बन जाएगा. सो इसकी वजह से क्या होगा, इट विल अवॉइड द प्रिंसिपल्स ऑफ कितना ब्लू होना चाहिए, कितना वाइट होना चाहिए. Because of it is following the rule of this data distribution, it will create something which is actually like this. So that's why, based on the new old images which are clear and everything, it will understand how to noise, and it will train the neural network to denoise. So that's how you create realistic images. So again, these points, whatever points are here, they will come back to the same you know distribution. And this specific distribution, यहाँ पे ये वाला जो point है, it is not before, like before in probability distribution, like about the data distribution, it is not there. And because of that randomness, when it got back here, it was a new point based on the knowledge of these specific points. So initially you have certain images, you don't have this image because it is made up of the knowledge how this data is spread. So that's how you create new images. So that's how you do diffusion models. That's how these specific models work. So they are purely probabilistic, dominantly probabilistic. एंड गॉसियन डिस्ट्रीब्यूशन से काम होता है. एंड यहाँ पे n ऑफ जीरो एंड दिस साइन इज नथिंग बट नॉर्मल डिस्ट्रीब्यूशन है. एंड उसका जो मीन है वो जीरो है. एंड यहाँ पे वो सिग्मा स्क्वायर आएगा. वन सेकेंड. सो दैट्स हाउ यू रिप्रेजेंट डेटा हियर. तो यहाँ पे दिस इज normal distribution. This is nothing but Gaussian distribution. Okay. Here we have certain problems which you can solve, and that's it. Summary में mean is nothing but the central part of the whole, data distribution, that is center of mass. Variance is how it is spread, the length between the point and the mass, the mean. So how in length it is varying, how far from mean it is staying, each data point. So that is variance. And covariance is the joint probability, like what is the relation between x1 and x2. And correlation का मतलब ये होता है कि normalize, like the angle between both of them, that is covariance, that is the angle theta, cosine of that specific angle. So geometry के अंदर वो चीज आएगी. This is correlation. And independence का मतलब ये है कि x1 and x2 how it is independent. If it is independent, covariance will be zero, but not vice versa. मतलब covariance will be, if covariance is zero, it denotes that it is linearly independent, and it does not denote that they are actually independent. Like x1 is x2 can be independent linearly, but if you take equation x equals to y equals to x square, so you will write 0x plus x square. So we are thinking about only this specific part, this specific term, linear. ये तो नहीं है, so it will give zero here. But we have this thing, so it will affect. So next we'll be discussing about Gaussian distributions. Like हम जैसे मैं पढ़ा था ये वाला specific notation. This you will be understanding in next upcoming sessions. So the motto of this specific probability, why I started with probability, not any algorithms and every stuff, is this you can find everywhere in YouTube. You can also find all this, linear regression, logistic regression, everything. But to develop that intuition, key geometrically how each term, how mean, mode, median, and how variance, covariance are calculated. This stuff only come when you study math, not just coding. Logistic regression को code करने से you won't understand. So you need to understand mathematics of it. Then only you can model new probabilistic, models. And these are the basics for cutting edge technologies like diffusion models and LLMs and all this stuff work on these principles. So if you want to understand research papers, new technology, so AI के अंदर जो भी new technology आएगा, unless you understand these notations, if you are not comfortable with these notations, you won't be understanding them. That's why understanding these notations is important. And the main thing is to integrate these concepts in whatever field you are. उसके लिए need to understand how models are working. That's it. And so this is the book we want to cover. ये तो बहुत बड़ा book है. Understand. So these specific things are okay. We are targeting this probability distribution, ये वाला 6th chapter, and this specific chapter. These two chapters will complete probability. So that's our motto, to complete this two. And Incharya Didi se baat hua hai, and she said like you take gap between two, for a week you take 2 to 3 days of rest and continue teaching this stuff. मतलब जितना free तुम हो उतना free आगे जाके तुम नहीं रहोगे, so you'll be not that free to explain this stuff, so you better explain, cover everything, and it will be useful for our batch, like for you all people, batchmates, and also will be a resource on YouTube. So in future, if you want to study any specific thing related to ML, you can go there and we can hear the own conversation which we had in past. That is the mode. So yeah, that's it. Thank you for hearing. I know today it is kind of confusing certain parts, but most of the things which you need to care about is mainly three to four terms, which is mean and covariance, variance, and correlation. These four parts you need to understand. And basically, you when you saw those graphs and everything, and when you saw that matrices, I hope you understood what it is and how it is related to ML. That's the thing. So yeah, if you have any doubts, you can ask me. I'll send the slides and everything. So next call, maybe I won't be having any session. So please do revise if you want to understand next concepts which we gonna discuss. So mostly next session से हमारे seniors भी आएंगे. So they will also participate in this discussion. So at that time, you should be good enough with these notations and terms which we have already discussed. Okay, thank you. So if you guys are having no doubts, you can leave. We can just take a screenshot of whoever is there up to now. Hmm. That's it. You can leave if you are, having your works to do.